record. Okay, so welcome to those who'll be watching the recording. In this session, as posted yesterday, what we'll be covering is the Architect Associate course, the lab from Module 6, which is known as Creating a Virtual Private Cloud. So we do have a couple of slides. Most of them are right out of that module. We'll just take a quick look at them. So here's our snapshot of VPC situated inside of the AWS cloud. So the AWS cloud, of course, is the entire thing. VPCs are a subset of that, as this green box is drawn. And then important to know, for knowledge sake and for exam sake, VPCs are defined within regions. So any given VPC is fully situated inside of a single region, but it can span multiple availability zones. So in this screenshot, we can see on the left, we have availability zone 1. There's nothing in it presently, but it is situated within this VPC. And then over here toward the center of the screen, we have availability zone 2. And in this one, we have situated 2 subnets, a public one and a private one. And we have some instances in both. So we have one instance in the public subnet, and we have 2 instances in the private subnet. And then let me move my chat box. To get access to the internet, we have an internet gateway, which gives access to and from the internet. This router is implied or is included. So if we were building a real physical data center, a VPC is certainly real. But if we were building an actual data center in our own facility where we could, look at and touch things, we'd have to purchase and install this device, which is known as a router. But in the case of working with Amazon, anytime we create a VPC, it is understood that they are providing us with a router. So that's that piece of equipment that takes the traffic from one network and sends it to another network. So the other thing we have in here is subnets. So subnets we should think of as logical network segments, and they will allow us to divide our network into smaller networks. And these are situated within a single availability zone. And we have the idea of a public subnet versus a private subnet. And what distinguishes one from the other is that a public subnet has an attachment to an internet gateway, and therefore it can get out to the internet. Right? If it doesn't have that, it's private. If we want to spin up a EC2 instance, we want to launch a server. That server needs to be inside of a subnet. So generally, the order of these things is to create a subnet and then to create an instance. And then we see also included in this diagram is the idea of security groups. A security group is a set of rules. Think of it as a firewall. It's a set of rules that secure the instances and determine to where and from where traffic can go to and from an instance. And we have this idea here of CIDR notation that's used throughout the various courses. This is how the internet itself works. So this is, not specific to AWS, but this is specific to the operation of the internet. And we refer to these as CIDR blocks. So this sort of light blue column over here toward the left of the screen. And here's a couple different ones. So 10.50.1.0/24 is an example of a CIDR block. And what that tells us, what that determines for us is what IP addresses are available for us inside of that subnet. So the 24 part is known as the mask. And what it's telling us is that the first 24 bits will determine the network, and the remaining 8 bits will be available to us as hosts. So over here, under the bit representation, the X are showing us these are the bits that we have to work with to assign hosts, which usually are EC2 instances. And the range of addresses, therefore, that we have are from 10.50.1.0, right, in a range going up to 10.50.1.255. So it's how we can carve up the space that we're given into these smaller sections known as subnets. This last number, the number after the slash, as that number gets bigger, the number of hosts gets smaller. And as that number gets smaller, the number of hosts gets bigger. This bottom number we see quite a lot, the 0.0.0.0/0, and that's just sort of a notation to communicate that we're talking about any address. It's kind of like a wildcard address. So when we're connecting to the public internet, we'll often designate it that way. I mean, any IP address with any mask, we refer to that way. So here's sort of a key to how many hosts you can have for a given range. So in the last example, we had 8 bits, right? So here, over here, where it says 2 to the 8 equals 256, that means we have 256 addresses to use when we have 8 bits. Just go back to that slide. Okay, so this case here, 10.50.1.0.24. This is the case where we have 8 bits for our use, right? There are 32 bits in total. So if 24 are for the host, therefore 8 are available to us. And that 8 translates into us being able to have 256 addresses. The nice thing about these base 2 numbers is as they increase, they double in size, right? So 2 to the power of 2 is 4. Therefore, 2 to the power of 3 is double that. And you could put yourself anywhere on this chart, like 2 to the 10 happens to be 1024. Therefore, 2 to the 11 is double that. So every time you add a number, you can double the number of hosts you can have, right? And going in the other direction, if you go from 2 to the 10 to 2 to the 9, you see you drop down from 1024 to 512. So here's some basic facts about VPCs that we're expected to know. And they don't ask these questions explicitly, right? They ask questions which are a little more subtle and nuanced and a little harder than this, but they do expect, in order to answer the harder questions, that you understand these basic things. And by knowing them, you can often rule out some of the answers. So here's a high-level look at a VPC. right? VPCs can span multiple availability zones, right? They are situated within a single region, right? As drawn by this blue dotted line. VPCs have an implicit router. So we talked about that in the earlier diagram, right? You create a VPC, that router is just there. It's not a step that you have to take. VPCs also have default route tables. When you create a VPC, you're given a route table. And the route table that we are given by default is a route table that allows all traffic to be routed locally. And that's what we're looking at over here. So it's saying that any traffic whose destination is 10.0.0.0/16, anything that falls into that range at all is a local address to us. You can think of it as being on the same physical wire as us. Okay, here's a little more about subnets. So subnets are used to segment the VPC address range and provide logical groupings. And sometimes one way to divide them, as they suggest here, is to have your EC2 instances and database instances or resources with different visibility in different subnets. So for instance, you could have a subnet also by department. So the marketing department could have their subnet, the production department could have theirs, the engineering subnet. So groups can be responsible for their own collection of resources on the network. And the way to do that is to put them into individual subnets. Okay, and then there's a rule that this is good to know for the exam too, that in a given VPC, so you're responsible for a VPC or you create a VPC, you can you can have or create up to 200 subnets in any given VPC. And so this slide is about route tables, and we'll work with route tables in this lab as well. So a route table is a mechanism used for routing traffic that originates from an associated subnet in a VPC. And what a route table is a set of rules, right? But we call them routes, but you could think of them as rules. And what they determine is where traffic is going to be sent. So a route table consists of a destination and a target. So looking over here in subnet 1 at our custom route table, this is telling us here that any traffic we have, so any type of communication we're trying to send out to anything in that range, we should send it out locally. And anything we're trying to send out to the public internet, 0.0.0, we should send that to the internet gateway. And then we have a route table here associated with our private subnet as well, right? And our private subnet only has access to the local addresses, and we should send them locally. Want to send something to the public internet from the private subnet here, presently we can't do that in the given configuration. Okay, and every subnet needs to have a route table associated with it, and you can only have one at a time. So security groups will be working with inside of this lab as well. So here's an example of what security groups look like. So security groups apply to our instances. We generally talk about them as applying to our EC2 instances. More specifically, what they're applying to is the network interface on any given one of those EC2 instances. So you do hear them described both ways. So by default, a security group is set up to deny all inbound traffic. So nothing can come into your EC2 instance from the internet, but it does allow outbound traffic. So you can browse out to the internet by default. So another thing that comes up on the test is this idea of statefulness. So what they mean by stateful is that if a rule allows traffic to flow in one direction, then responses can automatically flow in the opposite direction. So we have outbound rules and we have inbound rules. They're described by the type, the protocol, and then ports. Here it's saying port range, but usually we just refer to these as ports. And then source, where the traffic's coming from. Okay, I think we'll skip these lengthier ones for now. Okay, let's go. Let me get over to the lab. So we are in architecting. Let me find that one, cloud architecting. Okay, this is what it looks like within module 6, guided lab, creating a virtual private cloud. And what I just usually do before I start it is just glance up, make sure I don't have any console tabs open in my browser. Sometimes you can get tripped up if you've recently done a lab and there's some confusion whether you're presently logged into the console or not already. So it looks like mine is clear. So in that case, I will start this. So I'm just going to pause the recording briefly. I've noticed they take a little while to start up these labs lately. Read through the lab. Okay, so we've started up our lab, and we'll take a look at what it's going to offer for us. So it's going to remind us that traditional networking is difficult and involves all sorts of equipment, right? Routers and switches and cables and all kinds of specialist skills, and that Amazon's virtual private cloud is going to hide the complexity and simplify the deployment of that. And in this lab, we're going to build our own VPC and deploy resources and create private peering connections between VPCs. Okay, I thought that was actually a separate lab, but we'll see if we're going to do that. So the steps are deploy a VPC, create an internet gateway, right? Attach it to the VPC, create a public subnet, a private subnet, and then create an application server on which we'll test the VPC. So I believe they're going to give us a little PHP script, and a little bootstrapped web app. So we'll spend a little time exploring that too. Make that a little smaller. Okay, so we're going to create for ourselves a lab VPC, right? 10.0.0.0, 16, and then we're going to divide that up into a public subnet of with a /24 and a private subnet with a /23. Make it bigger again. Okay, so this has stopped spinning. So I think that means we are good. Is that you guys understanding too? Once that stops spinning, the lab has started successfully?
Yeah.
Okay, so let me click on the AWS tab to launch the console. Okay, step 5 tells us the service we're looking for is VPC. And then we're going to look at our VPCs. And we're being told that a default VPC is going to be provided so that we can launch resources as soon as we start AWS. And that there is also a shared VPC, which we will use later. However, in our first step, we're going to create our own lab VPC, which does not exist. Okay. So let's click on VPC. Okay, so here's the one they are letting us know to expect to be there. So a shared VPC, which we will use later, and this default VPC. So if you actually create your own Amazon account and the first time through, you'll actually have one of these 172.31.0.0/16 CIDR address. So in our case, though, we're going to create a new one. So we want a 10.0.0.0/16 called lab VPC. So I'll click create VPC, the big orange button. And here we want 10. And we're going to take the defaults for everything else and create this VPC. Okay, we'll get that green banner up at the top that we were successful. I believe you'll likely see the same message, which you can safely ignore. This failed to load rule groups. I think I recall seeing that before. So don't be too concerned if you see that. Okay, they're going to have us go in to edit the DNS host names. And this option is going to assign a friendly DNS name to EC2 instances in the VPC. And they usually look like in the form here that they describe. Right, so it tells you where it is, and it includes the IP address and that it's EC2. We don't actually have any instances yet, but when we create some, then that will be the DNS namings that they'll have. Okay, so let's go ahead and do this step. I think they actually changed the behavior of this step, but we'll take a look together. Let's see. Edit DNS host names. Oh no, it's the same. Okay, my mistake. Okay, so we're going to enable that there by checking this box. Okay, next it comes up and tells us subnet is a subrange of IP addresses inside of our VPC. And that when we launch resources such as instances, they need to be launched inside of a specific subnet. And those that are going to be connected to the internet we'll refer to as public, and those which are not we'll refer to as private. In this next task, we'll create a public one and a private one. Okay, so we're going to go over to the subnet services section over here. Let me go back. I'm just looking. I don't see my the VPC I'm expecting to see. Okay, here it is, lab VPC. So our lab, it's good to make a mental note of these VPC IDs, because as we're going to go to these different tabs of subnets and gateways and route tables and so forth, we're going to be asked to make the association to the VPC in question. So our lab VPC is this one here, FC03. FC03. So now I'm going to go to the subnet tab. So this is showing us the existing ones. So there's presently no subnets associated with our VPC FC03, right? Because we haven't created any yet. So the one we're going to create, that's where we're going to tell it it should exist. Okay, and that's the first question over here, right? Into what VPC do you want this subnet to be created? And I'm looking for this one that's labeled lab VPC, and the one that ends with FC03. And it's showing us that the CIDR range for that lab VPC, as we know, since we just created, is this space here, 10.0.0.0/16. So we're going to carve out a subsection of that. And Let me just glance over at my notes for what to call this thing. So I'm going to call this public subnet. And I think they're going to have us create them in more than one availability zone. So let me just show you guys back that in the lab for those of you who haven't completed it before. Okay, so for availability zone, you're going to select the first one that shows in the list. Okay, so in my case, it's 1A, East 1A. Okay, so we're now going to configure that subnet. So it will automatically assign a public IP address for all instances that are launched in it. Right. So all we've really done is we've designated or carved out a bunch of addresses, right? And these addresses are the address we're going to apply, right, to the network interfaces of our instances. And so the way we want these IP addresses assigned is if we want a public IP address, we can ask Amazon to do it for us. So that's what we're going to do over here. Okay, so let me go back. Okay, so we're going to enable an auto assignment of IPv4 addresses. Okay, so we can see all this information. So the CIDR block for this particular public subnet is 10.0.0.24, right? Meaning we have 8 bits for hosts, 8 bits for hosts, so we can have up to 251 hosts. We can also see that we're situated in US East 1. And then we could get more detail too by looking at these other tabs. Okay, so we can see that we've been given a route table. Right? We can expand upon it, but presently what it has when we first create a subnet is we're given a route table that gives us access to all of our local machines. So there's a single route which says, hey, to get to any of these local addresses, just do so locally. We're going to have a network ACL created as well. Network ACLs are specific to subnets. So the range for a network ACL is a subnet. Unlike a security group is controlling the firewall, or the boundaries for a security group is an EC2 instance, but the network ACL itself is what it's controlling is everything within the subnet. And what we're going to have by default is we're going to have an allow, and we're going to have an allow. So the behavior of these, and these questions on the ACLs are asked on the exams as well. So these ACLs have two sets of rules. They have a set for inbound and a set for outbound, and each of the rules is numbered, both the inbound rule and the outbound rule. And we actually have a slide that's going to look at it. The behavior of these is that the highest number of rules will be looked at first, and as soon as a match is found, then that is the access which will be granted. So for instance, looking at this is the inbound rule for the present subnet. So the ACL inbound rule for this subnet, the highest one, or think of it as the most important one, because it's the one that's going to be evaluated first, says that all traffic from anywhere is allowed, right? So now below that, we have one that says all traffic from anywhere is denied, right? But that second one is never going to be evaluated once we get a match on that first one. So, we're used to hearing that everything is kind of closed down and denied by default. And that's true with most things, like with the security groups, but it's not true with these ACLs. Okay, and then there needs to be matching outbound rules. So remember we said that we have this idea of stateful and stateless. So ACLs are said to be stateless. So just because traffic is allowed in one direction, that does not imply that it is allowed in the other direction. So in the case of ACLs, you need to explicitly state an inbound rule and an outbound rule. Okay, and as we can see, this one has an allow also. Generally speaking, as we add rules here, we do it in increments of a fairly large number. So we could have rule number 100, and then rule 200, and rule 300, so that if we need to incrementally put another rule in between, we have plenty of space in order to do that, right? Because the order of precedence matters a lot here. The highest number rule is going to rule the day. Okay, sorry, I just got a text that distracted me. Okay, so we're just looking at some subnet stuff here. Okay, I don't think there's anything else here we need to look at. Okay, so we've created our public subnet, and we've set it up for auto assign for IPv4 addresses. So I believe we're going to create an EC2 instance, and we'll see that we'll automatically get a public IPv4 address. Okay, and then there's a little kind of reminder here that's the lab is telling us, even though we call this subnet the public subnet, right? It's not really a public subnet yet until we actually go ahead and create a gateway and set a route to it and everything else, right? Just giving it a name is just one step in the process. Okay, so next up, we're going to create a private subnet inside of the same VPC. So it tells us in step 15, hey, do the same thing you just did before. This time, you're going to create it using these parameters. So it would be 10.0, 20, 23. So I'll create a new subnet. Have to be careful, make sure it's in the lab VPC. Right, it's not the topmost one, so you do have to read. You can either make sure it says lab VPC or make sure it has the address associated with your lab VPC. Private subnet. put this into the same zone as before, which in my case is 1A East. Okay, then it explains to us that the CIDR block we are now creating /23 includes all the IP addresses that start with 10.0.2.anything and 10.0.3.anything. So remember we said that as this number here gets smaller, the number of hosts gets larger, right? So our public subnet had a number there for 24, right? This one now has a number of 23, so this gives us double the number of hosts. So this is twice as large as the subnet that we just created. Okay, and it's also going to let us know here, hey, this is kind of expected behavior, because the general recommendation is that resources you're creating should be private unless you have some specific reason that you want them to be public, such as a public web server. So it's not unusual to have this mix where the subnets, which are private, have a smaller number here because more hosts are going to be situated in that subnet. So 23, remember the number, the total number here is 32, right? So 32 in mind, we're using 23 of these for host. So that leaves us 9 bits, right? So if we go back to that slide that we had, if I can find the right one, this one over here, 2 to the 9. So with a /23 network like we're creating here for this private subnet, we can have up to 512 addresses. Okay, and that's what they're talking about over here. Okay, twice as large. Okay, so next step is task 3. It tells us an internet gateway is horizontally scaled, redundant, and highly available. So we see this term a lot as well. So inside of AWS, the 2 terms that we hear are horizontally scaled and vertically scaled, right? It comes up on the exams across the board on different exams. So when we're talking in AOS world, that we say something is horizontally scaled, it means we've scaled up by creating more of them, right? Or we've scaled down by creating less of them. So if we're talking about servers, for instance, to horizontally scale servers, we would go from 1 server to 2 servers to 3 servers to 4 servers, right? And so forth. Or in the other direction, if we are scaling down, but then we have vertical scaling. And when we scale vertically, what we're doing is we're making our servers larger and more robust. So if we had 32 gig of memory, we could scale up vertically by doubling that memory. If we had 4 CPUs, we could scale vertically by adding 8 CPUs. So horizontally means more, and vertically means bigger. Okay, redundant just means there's no single point of failure. And then available means means accessible now. So, ready for use. So all these words kind of pop up a lot on the exams. So the internet gateway, which we're about to create, again, this is something that's going to be pretty automated. And so what they're telling us is when we go ahead and create an internet gateway, we don't have to say how many. We don't have to say, well, how big should that computer be? How much memory should it have? Should we configure it for redundancy or availability? What they're pointing out to us here is, no, you don't have to do any of that. You just create the gateway. The AWS service will take care of the rest. Okay. So what an internet gateway does for us is it provides a target in the route table that connect to the internet. So we'll see any traffic that's going to be designated to the internet will be pointed to, right, or routed to a target inside the gateway. And it'll perform network address translation for instances that were assigned public IPv4 addresses. Okay, so next step, step 16 is where we are. We're going to choose internet gateways, and we're going to create one, and we'll call it Lab IGW. So let's go ahead and do that. Internet gateways is over here. Okay, so there's one already, but it's not part of our VPC. It's one of those that was provided at the start of the lab. So, expect to see that. That's not the one you need to be concerned with, though. You're going to create a new one. Lab IGW, and then create internet gateway. Okay, so we now have it. It's called Lab IGW. Not in use. In fact, presently it's detached. So if someone were to ask about the state of this thing at the moment, we have it, but it's not connected to anything else in existence. So it's detached. Okay, it tells us, hey, you can now attach that to your lab VPC. Okay, so we're going to choose actions, then attach to VPC. And we're going to make sure we point it to the right VPC. And then we're going to attach it. So here's our action tab in the upper right. So let's take this internet gateway, which is just kind of sitting out there, not connected to anything at the moment, and we will attach it to a VPC. Okay, in this case, ours is up on top. So we're going to connect it. So once you make that connection, the word goes away. So you'll notice right now it's showing me the VPC ID and lab VPC, but once you click it, the lab VPC goes away. Okay, so but FCO3. Yeah, and now I don't remember if they always did this, but they're doing this now where they're showing you the CLI command. If you wanted to do this from the CLI, they're actually giving you the command here as well. So you can actually see it down here, right? AWS, EC2, attach gateway, blah, blah, blah. Right? And you could copy it and do it that way as well. Okay, but we're just going to do it the way we have in the lab, and we'll say attach the internet gateway. Okay, now we can see it's successfully attached, and the VPC it's attached to is our lab VPC as we want. Okay, and then at the bottom of step 18, it's telling us the action of attaching the internet gateway is a necessary one, but you must also configure the subnet route table so that it knows to use the internet gateway. So even though we've told that internet gateway that it's associated with our lab VPC, it's just one step in the process. The route table is another necessary step. And that's what they're going to have us do in task 4. Okay, so route table contains a set of rules, and we call those rules routes. And what it will determine is where the network traffic is directed to. Right. If you think about it, what we actually have here is we have kind of everything physically connected. So we have the capability of sending traffic almost anywhere in a physical sense. There's connections to them, but what's going to control where traffic can go and where traffic can't go are these things like route tables and security groups and ACLs and everything else, right? The physical connectivity is already there. This is kind of giving it the brains of telling it where to go to actually get the traffic to the desired state. Okay, each subnet in a VPC must be associated with a route table, right? Because the table controls the routing for the subnet. A subnet can only be associated with a single route table at a time. But if you have a route table, you can associate that route table with many different subnets. So next step is explaining what our use here. So to use an internet gateway, a subnet's route table must contain a route that directs internet-bound traffic to the internet gateway. And if a subnet is associated with a route table that has a route to an internet gateway, it is known as a public subnet. Right? So this is really actually the definition of what is meant by a public subnet. Public subnet is one in which an internet gateway exists, right? And we have a route entry to it. So if those things are all true, it's a public subnet, right? Whether you call it public subnet or Brian subnet or Mary subnet or any name at all, the name doesn't matter. It's that concept of having an internet gateway and a route to the same. Okay, so the next step, we're going to create a public route table for the internet-bound traffic. We will add a route to the route table to direct internet-bound traffic to the gateway, and then we'll associate the public subnet with that new route table. Okay, so in the console, we're going to choose route tables, and we'll see that several are displayed. There is only one associated with our lab VPC. This route table routes traffic locally, so it's called a private route table. And what we want to do, we want to select the route table that shows lab VPC. Let's go to the end so you can see lab VPC. Okay, let me go step by step since I'm getting slightly confused. It looks like it's telling me about private and public kind of at the same time. Okay, several route tables. There is one with the lab VPC. Okay, let's go to route tables. So here's our lab VPC. Depending on your screen resolution and so forth, you can expand these columns or reduce these columns, right? Make sure you can find the one that says lab VPC. That's this one over here. So this one presently, I think this is the default one. So let's take a look. Right, so this one is presently only allowing local traffic. And what they want us to do is refer to this one, give it the name of private VPC. So let's just go back over here. Okay, so there's one route table associated with our lab. So it's called a private route table. Back in the left, select the route table that shows the lab VPC using the little pencil icon. Enter the name private route table. So you have to hover over this for that little icon to show up. Okay, and then there's a little save button right below. Just, before you click it, make sure you're on the right row, right? The row should line up with the VPC, which is identified with the lab VPC. So in my case, it's this second one. And then it tells us step 23 in the lower half of the page, take a look at the routes tab. There is only one route. It shows that all traffic destined for 10.0.0.16, right, which is the lab VPC range, will be routed locally. This route allows all subnets in a VPC to communicate with each other. Okay, so that's where we are. That's this idea over here. So what we're going to do is for our public subnet, we're going to create a new one. Okay, so step 24, we're going to create a new route table. We're going to call it public route table, and that's going to be associated here with the lab VPC. Create route table. Okay, now in the routes tab for the new one, we're going to create edit rules, and we're going to add a rule to direct internet bound traffic to the gateway. Okay, this is our routes tab over here. So we do want to continue to send local traffic locally. So we want to keep the destination of 10.0.0.16 local, and we want to add a second one. Okay, so the target for traffic bound for the internet, right, for 0.0.0.0/0 is going to be our internet gateway, right, the one we named lab IGW. Okay, so that's step 25 and step 26. And then it tells us the next step, right? The last step is now we need to make an association with this new route table with the public subnet. So there's going to be a subnet associations tab. So presently, there are no subnets associated with it. So we will edit subnet associations. And we want this one associated with the public subnet. Okay, so now we have two routes. We have a route for local traffic, and we have a route for the gateway. Okay, and then they remind us here that the public subnet is now actually public. Even though we named it public a long time ago, now it's really public because we now have a route table entry that sends the traffic to the internet via the internet gateway. Okay, so task 5 is creation of a security group for our application server. Anybody have any questions so far? Or comments? Anything at all they'd You guys okay without a break? Because we could take a short break if anyone would like. Anyone has a dog that needs to be walked or a phone call that needs to be made or something?
I'm okay without a break.
Okay, thank you. Okay, so it sounds like everybody else is willing to forge ahead as well. So we'll move on to step 5. So step 5 is this security group one. So a security group is going to act as a firewall for instances, right? Which are our virtual servers. And what they'll control is inbound and outbound traffic for a given server. Right? More specifically, the network interface on those servers, but we kind of say it both ways. And here they tell us security groups operate at the level of the elastic network interface for the instance. Security groups do not operate at the subnet level, right? Remember those ACLs operate at the subnet level. Security groups operate at the network interface for an instance level. So each instance can have its own firewall that controls traffic specific to it. If you do not specify a particular security group at launch time, I almost said lunchtime, if you don't specify, then the instance will automatically be assigned to the default security group. Okay, so on this next task, we'll create a security group that will allow users to access your application via the web protocol. So let's go to here. So let's get back over to here. Now we're going to the left side of the screen and we're going to find security groups. Okay, so we have a couple of existing security groups. Okay, but we do not have any associated with the VPC that we created oh, actually we do. We have the default one over here. So we have this default security group, which is the one associated with our VPC. So let's see if that's what it wants us to do. So now it's going to have us go ahead and create a new one in step 34. So let's go ahead and do that. So this will be our application security group. They have us calling it app-sg for application security group. And the description is going to explain what it's doing. So in this case, it will be allow hypertext transport protocol traffic. And the VPC needs to be our lab VPC. Okay, so in my case, just for those of you who haven't done this before, I had to actually click that X to get the default to go away. And once I did so, I was now given a choice. So here I can correctly identify the lab VPC as what I want. And we'll go ahead and create it. Let's just get back to the instructions here. Oh, actually, the lab step is telling me to expect the behavior I saw, which was click the X to clear the selection so you can pick the one you actually want. Okay, now we're going to verify the inbound rules. The settings for inbound rules determine what traffic is permitted to reach an instance. We're going to configure the rules here to permit HTTP traffic. So this is one of the more common ports. You know, you don't have to memorize all the various port numbers, but the ones we see a lot are port 80 for HTTP and port 22. You've seen in a lot of these labs, right, for SSH, and port 443 for HTTPS. So some of the more common ones, it's not bad to be in the habit of kind of knowing those. So we're going to edit the inbound rules, and we're going to set up this rule over here in step 35. And add rule. And we're just looking for HTTP. I've never quite figured out the ordering here. Maybe it's by port number, but it's not alphabetical. 80 maybe. Anyway, so we want port 80, and then the source we want to be anywhere IPv4. And 0 is correct. And description, allow web access. Okay, so we're actually not setting this up for port 22, which we do in a lot of the labs, which suggests we're not going to be SSHing in to this particular instance, would be my guess, since we haven't turned on that port. Okay, so we're going to use this security group that we just created in this next task, which is task 6. So task 6, launch an application server inside the public subnet. So to test that our VPC is correctly configured, we'll now launch an EC2 instance into the public subnet, and then we'll confirm we can access it from the internet. Okay, so we're going to go out and find the EC2 service, and then we're going to launch an instance. okay, with all of these settings. Okay, so let's go back to the VPC. I'm going to kind of work from a hard copy rather than jump right back and forth, but this step we're working on right now that we're about to work on is step 37. Okay, so presently we have no instances. So we're going to go ahead and launch our first one. Okay, it's going to ask us the usual questions here. Let's see, what do we name it? I think we call it lab server. I'm not actually seeing that step. So we're looking for Amazon Linux 2. So it looks like we're taking the default one. And then for the type of computer, the hardware is which is the instance type. We're looking for a T2 micro. Looks like this is coming up with all the defaults already, actually. T2 micro. Let's type. Let me see. Okay, I'm just going to come back here since the screen doesn't quite align with this. In the list of available quick start AMIs, keep the default selected. T2 micro, keep that selected. And then select VAC key, and then we're going to edit the network. Okay, sorry about that. And then they're going to have us edit the network section so we can pick our VPC. Okay, the default is taking that default one, so I have to be careful you don't take that. And we want to launch this EC2 instance in the public subnet, so that's correct. And it's in zone 1A. It's telling us, reminding us. Remember, we have 8 bits of host space, which is 251 addresses. Right, so it's actually 8 bits gets you 256 addresses, and Amazon uses 5 of those for their purposes and for some general networking purposes as well. So we get 251, so that's correct. And I am role. Let's see. under here. Okay, so under in this bottommost section that says advanced details, there's a IAM instance profile. We're looking for inventory app role. Inventory app role. Scroll back up. Just see what it says here about security group. Under firewall security group, select an existing security group and then app SG. So I want that checkbox. Okay, this is the one that we created. Remember, this is the one that gives us inbound access on HTTP. We'll take the default. Default for the storage is fine. And then this instance profile is important. Let's see if I'm missing anything else. So under the advanced inventory app role. Okay, and then this particular launch is going to use user data, meaning the instructions, these commands are going to execute for the first and only time when we launch this instance. That is when we boot it up for the first time, along with booting the Linux operating system, that AMI that we chose will also execute all of these commands. So I have to grab these, make sure I get them all. I'll just use the keyboard shortcut of Control V. Okay, so I assume the lab is going to step us through an explanation of these things, but if not, we'll do so together on our own. Okay, so we've got everything, and what we'll do is we'll say launch instance. Okay, so we have successfully launched the instance. Just going back, we'll take a look at it. So we had 0 to begin. We should show 1 now. Okay, so here it is. We called it the app server. It's in the running state. It is in fact T2 micro as we requested. Still initializing. It's in US East 1. Remember, in an earlier step, we chose to have public IPv4 addresses auto-assigned to any instances created in this subnet. And so that's what happened for us over here. We're associated with the app SG. We created that together as well. Okay, so let's give this a second. I'm just gonna move my Zoom toolbar, then we can do a refresh here. Sometimes if something under status check is showing like initializing, you don't always see the transition to the next state without refreshing. So every once in a while, it's necessary to hit that refresh button. Okay, looks like it's still working on it. So let's come back and we'll see where we are here in the lab. Okay, it's going to tell us wait until the app server instance shows 2 of 2 checks have passed in the status column. It may take a few minutes. Choose the refresh button at the top every half minute or so. Okay, then once it completes, we're going to select that app server. We're going to grab its public DNS value. And we're going to open a browser tab and see if we can open that up. So it's going to say, if you configured the VPC correctly, the inventory application and this message should appear. And it says, please configure settings to connect to the database. You have not configured any database settings yet, but the appearance of the inventory application demonstrates that the public subnet was correctly configured. If the inventory app does not appear, wait 60 seconds and then restart it. Okay. Let's refresh this. Okay, so here's our 2 of 2 checks that have passed. Just going to grab the IP address here. We'll try it with the IP address. I'm going to open up a new tab. Okay, and we got the requested web page, came back. Here's the app. It's going to run an inventory application. And I think it was telling us that, let's go back to what it's actually telling us with regard to the functionality of this lab. The inventory application and the message should appear. Please configure the settings to connect to the database. We've not configured the database yet, but the appearance of the inventory application demonstrates the public subnet was correctly configured. All right, let's see if it's supposed to actually work. Please configure settings. So there's settings. Oh, I see. We don't have this information. Okay. I guess we follow up with this in a later lab. Okay, I think then we're actually done submitting your work. Okay, so let's scroll up. What I'm looking for is the user data. So those Linux, here we go. Where are they? Like step 37. So what it's doing, there's like a wealth of information oftentimes hidden in these labs, and if you choose, if you have extra time and you want to explore them on your own, you can go ahead and do so. Of course, you could mentally check the box and say, I completed the lab. That's good for its own purpose and value as well. But if you want to look further, you can actually go ahead and say, hey, what are we actually doing when we launch this server with this user data script, right? So these are comments. So anytime we're looking at user data, you see this pound sign or this hash character, this acts as a comment. So it's going to kind of step us through what we're doing. So over here, we're installing the web server, the Apache web server, and we're also installing PHP. So the Apache web server is this HTTP daemon, right? And then MySQL. So those both are being installed. Yum is the Linux update manager. And then over here, we're installing PHP. Looks like version 7.2. I'm not too familiar with the versions of things here. And then we're downloading lab files. So we're going to actually get these from the internet, right? And it's a zip file. So look what we're doing. We're doing two separate things. So this is one command, right? We're doing a get from the World Wide Web. So wget means go out to the internet and get this file, and everything else is just a path to it, right? This directory is where it's located and so forth. And so we're pulling in a zip file to our EC2 instance, right, at boot time. And then we're going to unzip it, right? And then where we're going to put it is over here, right? This is the, we've seen this path many times before. This is where we put content that's going to be served up to the internet, right? This var www HTML directory, right? That's where we're going to put the contents of what we're unzipping. So we're going to unzip it, and where we're going to put it after we unzip it is over here. And if you wanted to get a local copy of this, you could do that as well. That's like not a bad thing. If you want to explore a little more about the details of these labs, you could actually just grab this, right? Starting with the HTTPS, right? And going all the way to the end where it says zip, we should be able to make a local copy of that. So now I'm just connecting to it from my local computer. Right, and here it is over here. I'll just create a folder with today's date for now. Right, now you can look at all this cool stuff. When I say you, I mean you and me, because I'm going to look at it too. Right, so here's the app. This is the app that's now running, right? We connected to this app on the EC2 instance that we launched together, right? And this is when we used user data, this is the app that we launched. So if you want to look at this actual code, you have access to all these different PHP scripts. Index is the home page or the starting page. You could open this stuff up in an editor. Right, so it's all PHP code. It's It's using something called a Jumbotron. So if anyone spent any time working with the web framework, Bootstrap, the web framework known as Bootstrap, Jumbotron happens to be one of those components. And then this web page is also making reference to these different scripts as well. So there's a Bootstrap file, a jQuery file, a scripts file, and you have all of that information as well. So here, for instance, in the JS file, there's one called Bootstrap. So there's the Bootstrap code, there's the jQuery code, the scripts code. So there's really kind of a wealth of information in here if you wanted to explore, at a little more depth. So that app that we looked at together, this app here, right? It's a PHP-driven app, but it's also using Bootstrap for the interface. This big box here happens to be what Bootstrap refers to as a Jumbotron, this big box with the gray background. If you wanted to know what the SDK looks like for PHP, it looks like we can get a hold of that as well, right? Because look what we're doing next. We're doing, when we launch our instance, this launch command here says go out to the World Wide Web, right? And get this file. And this is a zip file as well. And what it is the SDK for PHP, right? So we're going to download that to our EC2 instance upon boot. And then we're going to unzip its contents, right? And put that out there as well. So that var www HTML file will have our entire web app, right? Everything we need, the user interface, the scripts, and everything else. Then we simply turn on the web server, right? And start it up. Let's see what this one has too. Just as long as we're here, we should be able. Anytime in any of these labs, when you look at one of these wget commands, which is the Linux command to download something from the World Wide Web, if you want to grab a local copy of it as well, I would say 99% of the time it's going to work perfectly fine. Just put it into a browser window, and then you can explore it locally, and maybe not immediately, but kind of have it as a resource for yourself. Yeah, I'll put it here for now. Okay, so we have access to all of that as well. AWS SDK for PHP. Okay, so let's see what we missed. I think we're actually near the end of the lab. If the inventory application appears, you are good. The database is not actually set up yet, right? Not configured, so we should be able to submit our work. Okay, so how do we do that? Anybody ever lose access to the submit button? Let's see. Close that one, close that one. Okay, browser maybe resize. Okay, Umer, thank you for that suggestion. I didn't see you here before. You are one of our long-standing participants. Glad you're still around. All right, let me try and make it smaller. It's the top. Try and make it bigger.
There is a section called action and grade, if you see.
Oh, now I see it. Thank you. Yeah, it was eluding my vision completely. Let me see if I can make it a little smaller. Do I still see it?
Yeah, you can see action.
Action, okay.
But not sure whether it will have that.
Yeah. Reset. Grade. Oh, okay. Well, that's good. That's some good information. So it looks like we made most of them. Lab VPC has a private route table. It doesn't like that one. Lab VPC has a private route table. Yeah, the whole behavior is kind of strange. I don't want to reset. Let me try and make it a little smaller again. Instruction.
Maybe you still might want to with those on the size of the window. It's still too big.
Yeah, it definitely looks too big. When I've been trying to make it smaller to see if those tabs would appear.
Okay. There you go. It's 100% now.
Yeah, but I don't see the way to submit it. Do you see the way to submit it? Here's the browser window itself. Yeah, I've had the labs trip me up in a number of ways. I think this is a new one though. Let me try and refresh maybe.
Oh, either try to go to the module again and then go to the lab again. Probably it will set up the module back to.
Yeah, without resetting, you think?
Yeah.
Good. Oh, we first just will do the same trick.
Yeah, we could try. Let me try. I'll try the refresh first, only because I'm afraid to go back.
There you go.
Yeah.
Okay. Okay, so let's see. So, okay, let's see if the grades are showing us what looks like a passing grade. Okay, I usually like to get 100, but I think 40 out of 45 will have to work for today. So we will submit it. Keep our fingers crossed. Hopefully it tells us we passed. 40 out of 45. And then somebody show me under details.
Yeah.
Under details, I could, is it show?
View submit report.
Oh, report. Okay, thank you. Yeah. Sometimes I have to be told twice.
No, that above
Oh,
one. Yes.
oh, views. Thank you. View submission report. Okay, so we created the lab VPC. We created the public subnet. We auto assigned public IP. We created private subnet. We connected the gateway. Oh, here's our problem. No route table named public route table was found, or it has not been associated with the public subnet. Huh. Not sure why that would be, because we had to, if we think about it logically, we had to be successful in creating a public route table, right? Because otherwise we would not have been able to access our app, right? You know, via port 80, which we did. So apparently we did create a route table and associated it. Otherwise we wouldn't have had access to the internet gateway. But
I think probably the name.
Yeah. You know, I think you're right. I think I might have seen that once before, where if you don't name something as requested, you know, on their side, because they're testing this, I guess, you know, the checking on their part is automatic. There's no human being reading it. It's just an automated process.
If you notice that next one says app SG. So if you name something, they will not treat it as well. So probably that is the case.
Okay, thank you. I think you're right. So that's probably good guidance for anyone who hasn't worked on too many of these before. When they say to name it XYZ, name it XYZ.
Yeah,
Okay.
I was about to say about the same thing. It's a testing issue, and we got this. So he has to do with
Yeah.
the
Yeah, I was probably not very careful in the naming, I suspect.
In fact,
Okay.
in one of my website, I stated I used index.html where the first letter is capital, so it didn't count it. They says everything should be small, like index.html. So.
Oh, really? So it was even case sensitive too.
Yeah, like
Okay.
especially on the if you are creating a static website.
Right.
That is something.
Yeah. Yeah. Okay. Well, lesson learned. Lesson learned. I think I have a couple quick questions here too, if you guys want to stick around. Let's see if I can find them. Yeah, just a couple. Oh, this is actually from last week. This has nothing to do with today's lab, but we did it in the last lab. What Linux command is used to view the contents of a text file?
cat.
Okay, so hopefully everyone got that one. that was a hint. Good, you're correct. So here's the questions that kind of relate to what we did today with regard to VPCs. So this is actually explaining the use case for the IP addresses which are reserved by AWS themselves. So remember, we said when we're working with 8 bits, right, we have 256 addresses, right, 2 to the power of 8. But the reason that we don't actually get the full 256 is that Amazon uses 0 itself as the network address. Actually, the internet community as a whole uses that. And then the address 1 is reserved for the router. And then 2 is reserved by AWS. And 3 is reserved by AWS. Right? And then the highest number, 255, we refer to as the broadcast address. So any interface which is on that subnet, which sees all ones, that's what 255 translates into being, we'll think of it as a communication to them. So it's like broadcasting out to everybody. So basically what you do is you say, I have 256 addresses, and these are the 5 that get subtracted. So if you're interested in those details, that's what this is for. Can I get that? Oh, this is a screenshot. Okay, now I was going to try and put it in the chat, but that's okay. So that's not a question. Next one is an actual. So here's a question. So which of the following are the recommended resources to be deployed in an Amazon VPC private subnet?
Database servers.
Database server is correct. Anything else?
And maybe Bastion host.
So
Gateway.
yeah,
No,
no,
I'm sorry, not gateways, not gateways.
yeah. No, so you were correct. The correct answer is C. This is one of those single choice, multiple choice type of question.
Right.
And when the one good thing about the Amazon exam, when they ask us a question, a multiple choice question, they do let us know whether they are looking for one selection or two, or how many they're looking for. And I didn't do that. I just kind of threw this question up. So your first answer is correct. Database server is the only one here that should be private. Internet gateway will be for public.
Okay.
Bastion host is that jump host thing. So usually the Bastion host itself is in a public subnet, and from there we can jump into a private subnet.
Private.
So,
Yeah.
and we'll see that in a couple different labs. And if you guys are with me in earlier weeks, we looked at the Bastion host as well. And a NAT gateway is a way to get from a private out to the public internet. So, but that would be situated in public as well. So the correct answer is the one you stated at the beginning. So question, it is C.
So A is not included because just as you said, you need to attach a NAT gateways to a private subnet in order to gain access to the public. So NAT gateway is not one of them.
The NAT gateway, yeah, well, the NAT gateway, which is a resource in itself, right? It's a service. It's an Amazon service that needs to be located somewhere. It would be located in public. And
Okay.
it would provide you could provide a path out to the internet to a private subnet, but the NAT gateway itself would be deployed in a public subnet.
All right.
So A, B, and D would all be deployed in public. So
A, B, and D. And I guess I'm just still confused with the fact that the question says all like plural, so it's supposed to be more than one answer, more than one answers.
yeah, it's worded a little trickily, but it should be one.
Okay, all right.
Yeah, I don't know. What word would you use instead, though? If you just wanted one, what would you say instead of which?
If I wanted one?
Yeah, if you wanted to tell a user that there's only one right answer, how would you word the question differently?
Which of the following is the recommended?
Which of the following is the recommended resource? Oh, recommended resource. Yeah, I think you're right. I have to agree with you. Okay, but we won't get too tripped up by it. But your answer was correct, and I think your wording is probably an improvement as well. Maybe they will hire you with the education department. Never know.
No, I'm not.
Not interested. Sorry, not interested.
Listening to that.
Okay, I won't volunteer you. Okay, let's move on to another question. Hopefully this one's a little better worded. So here one we have that says an organization runs several EC2 instances inside a VPC. We have 3 subnets. One is for development, one is for test, and one is for production. And the security team has some concerns about the configuration. It requires restricting communication across the EC2 instances using security groups. So what the question is asking is our knowledge of security group behavior. So which of the following is true for security groups? So take your time, read through A, B, C, and D, and which of those facts, just one, which of those facts is true for security groups? And you can think back, we've done this in a couple of the different labs in AWS with regard to working with security groups. We've seen the behavior. How about rule out? Can anybody identify any we can rule out?
I think C and D.
Rule out D.
Definitely D.
Yeah, so D can certainly be ruled out, right? The only security group you can change is the default security group. So we know that's not true. We've changed all kinds of security group stuff. So D you can throw away. And then C, you can change security group only if there are no instances associated with it. So we can throw that away too, because we've changed security groups after we've had them associated with EC2 instances. So it's either A or B.
I think A would be the correct, like we can change the security group while it is in running state.
Yeah, that's right. And we've done that in a bunch of labs. Remember, we've had like EC2 instances that we cannot SSH into. And we go into the security group and we turn on port 22, right? Without shutting the machine down, without suspending it, without doing anything to it. We just all of a sudden say, okay, let's turn on port 22, right? And then bang, it's working. So the answer they are looking for is for us to understand that you can change a security group with an instance that's in the running state, and it takes effect immediately. You want to turn on your web server? No problem. Open up port 80. Or you want to block access to SSH for there's some security concern or something. Okay, we can shut down port 22 on all the machines, and they'll continue to run, and everything is fine. So they can be changed on the fly. Okay, let's look at another one. Let's look at another one. So I got to move my Zoom toolbar to actually see this one. I apologize, it's a little small, but I can't really make it much bigger. So a company has defined network ACL rules. Remember, we said those are the rules that their scope is a subnet, so they apply to a subnet. We have ACL rules deployed in a subnet, which is associated with a route table that has an internet gateway. Okay, so we have a internet gateway out there. And remember, ACL rules, we have sets for inbound and set for outbound. Okay, so we have 3 inbound rules, right? Rule on the top, we have rule 100, rule 200, and then we have the wildcard one. And then for outbound rules, we have 100, 200, and the wildcard one. So it's saying what would be the outcome when a user tries to access via SSH to an EC2 instance launched into this public subnet from the corporate network? So let's take a look. Here's the actual rules.
I think it would be blocked.
Yeah, we'll look together. Let me go here. Whoops. Okay, so here's some of the facts that we'll see questions about. So each subnet must be associated with the network ACL, right? If you don't design one of your own, you'll get the default one. Subnet can be associated with only one at a time. Okay, a network ACL contains a numbered list of rules. We evaluate the rules in order, starting with the lowest numbered rule, right? Starting with the lowest to determine if traffic is allowed. Scroll down. I'm trying to find this section. Trying to find where they describe it. So here's an important fact. Rules are evaluated starting with the lowest number rule. As soon as a rule matches the traffic, it is applied regardless of any higher numbered rule which might contradict it. So looking at the lowest numbered rule, right? For inbound, we say all traffic is allowed. So even though 200 says SSH is denied, right? We never actually execute that rule. We essentially ignore rule 200 because 100 had a lower number and said to allow everything, right? So what we have here is we have an allow for SSH for inbound and allow for SSH to outbound. Okay, so as someone answered in the class, your answer was correct. The answer is it would be allowed. So we would be able to SSH to a machine with these ACL settings. Okay, so I've seen a couple of questions on the exams that they kind of expect to have a basic understanding of these ACLs. And this is a pretty good example of it. These actually predate the security groups is an Amazon thing. It's, you know, AWS invention. ACLs predate that. They existed before Amazon. Okay, so there's no multiple choice here. I couldn't quite fit it on the screen, but the answer is what would be the outcome when a user tries to access an EC2 instance that with this ACL rules, and the answer is they would be successful. They would successfully SSH into the machine. Okay, let's move on to another one. So this one here, I think this is a similar type of question. This one's going to throw a it's going to throw a security group into the mix. So here they're going to show us that we're looking at a situation where we have ACL rules, right? And we also have a security group attached. So you have the following network ACL and security group rules. What would happen to an SSH request sent from address 10.10.1.148 to an EC2 instance with the below security group and the below access control list rules? So could we putty in? Could we SSH into the machine that has these rules if we're trying to SSH in from 10, 10, 1, 148? Any thoughts? You guys want to vote in? You guys want to vote in chat? Any ideas? You think we get in or we don't get in? How about for the ACL part? Will we pass the test on the ACL part? in order to get in?
Yes.
Yeah,
Not
so it's
the-
the same. Thank you. Exactly right. The same as last time.
It's local.
The ACL will allow it because we'll look at the lowest number rule, and we'll see the lowest number rule happens to be 100, and it's allowing SSH on inbound, and it's allowing anything on outbound. Right. So with that in mind, now we have to do we pass the test with regard to the security group? So our inbound security group is allowing SSH, right, which is port 22, as we've seen in lots of these labs. And the source is 10.10.1.0/24.
Yeah. It's on the same.
Yes.
So yes is the answer. So the address range, which would be successful, is we can get into this machine from any machine that's at 10.10.1.0 through 10. I'll put it in the chat. 10.1.255. Because we have those 8 bits of space. So the thing to understand is that /24. That /24 means that the first 24 bits are going to be the address space, and the last 8 bits are going to be for the hosts. So we could have hosts for the entire what we call the last octet. Those numbers are referred to as octets. So 10.10.1.0 is 4 octets, and any number occupying that 0 position will be the last 8 bits, and we'll be able to get in. So that's a pretty common subnet mask. That's maybe not a bad one even to memorize, where that /24 means you have 8 bits of hosts, and you could have 251 hosts. Right, the ones we've looked at before. Remember, we said Amazon reserves a couple special numbers for themselves, the first 5 and the last one. So this request for SSH would work fine. Okay, I think maybe, do we have one more? No, okay, okay, I think we are done then. Okay, everybody, so thank you very much. We'll actually wrap up early. But thank you for your participation and working without a break as well. And I'll see you guys next. Wednesday.
Thank you, Professor.
Thank
Love
you.
the session.
Yeah.
Thank you so much, Professor.
Okay. Thanks, everybody. See you next week.